In this example, we'll look at wind power economics. Our goal is to calculate the levelized cost of electricity generated from wind power. We'll be using Mark's handbook. The equation is the cost of electricity equals the fixed charge rate times the initial capital cost divided by 8,760 hours per year times the capacity factor plus the O&M cost. The capacity factor is equal to the annual electrical production divided by 8,760 times the unit nameplate. What we'll be doing is to go through an example next of the fixed charge rate. We'll calculate that component of this equation on the next page. We'll start with the capital cost. A 1.5 megawatt wind turbine cost about $3,180,000. You'll see there on the first row the annual payment back to the bondholder at 5%. This payment's about $301,000 per year. The next row down, you'll see the investment tax credit at 30%. This provides the investor about $900,000 credit on the income taxes for the first year. Then we'll look at interest and depreciation. These are tax benefits. Once they're calculated and totaled up, we'll take an effective tax rate for this company and then subtract the tax benefit from these costs to determine the net after-tax cost each year. Now, the depreciation is for 5 years. The full example is for 15. I'm not showing all 15 years on the spreadsheet due to the limitations of size in the print. Once you calculate the depreciation using the modified accelerated cost recovery system, MAKERS, you'll put those numbers in and come to an after-tax cost for each year of the project. You'll take each of these after-tax values, bring them back at P/F 5% N to come up with a present worth cost of the wind turbine, the fixed cost. Once you get the fixed cost and a present value, you'll spread these numbers out using A/P 15 years at 5% to come up with the fixed charge rate. We'll now go to the second page. So we'll have cost of electricity at the fixed charge rate we just determined at 5.68% times the initial capital cost per kilowatt of $2,120 per kilowatt plus the O&M cost of 1 cent per kilowatt hour. We'll take those values and divide it by 8,760 hours in a year times the capacity factor and come up with the fixed component, which will be the first group of numbers. The fixed component comes out to about 3.34 cents per kilowatt hour plus 1 cent per kilowatt hour for the O&M cost, for a total cost of 4.4 cents per kilowatt hour. This number at 4.4 cents also equates to $44 a megawatt hour.